Okay, hello everyone. My name is Cameron.
I'm Ashwin.
And we are both part of and we're here to present our project, which is a transistor-powered multi-Arduino lattice with motion-based LED tracking integrating machine learning.
So in the past 5 or 6 years, the majority of innovations in technology have been in the form of touch-based things like smartphones and smartwatches. But we believe that touch-free interaction is the way of the future. And what we did is that we used IR sensors to track the position of the hand over a board and illuminate the corresponding LEDs.
A unique feature about our project is we actually used 2 Arduinos, and this decision required us to find a way to make those 2 Arduinos communicate via I2C communication, which was a big challenge for us.
So originally we just wanted to have a board that would track the position of the hand, but we realized that we could do so much more.
So some of these things that we decided to do was to integrate machine learning, which was a thing that we were presented to and we found really interesting, so we wanted to try to do it. We also, as I mentioned before, we had to learn I2C communication, and also we wanted to add more LEDs and sensors to allow a better tracking of the hand. We also have quite an original approach. We began by deciding to try to use this method called Charlieplexing. Charlieplexing allows for individual call numbers for each LED. We quickly found that this was kind of limited for our design, and we decided, okay, we're going to try something else. We're going to add transistors. Transistors allowed us to increase the power and gain more control over our device. So while our project may seem like it has not a lot of applications in real life, it actually does. Streetlights are on 24/7 during the night, almost. And what if that uses a lot of energy? So what if instead we had streetlights turn on only when it detects a car nearby, and then it illuminates the path in front of you and follows your car down the street?
And as I mentioned before, another big application is hands-free technology, where they would use microsensors to basically track the hand to individual LEDs on a board. And so here's a sample of our code. This first one is for the machine learning, where it basically compares the data obtained from the sensors to predetermined sets. And if the average of that set is similar enough to the average of the other sets, then it would run the predetermined code. And on that side, we have the code for our second Arduino, which is basically just the positive end. It receives signals from this one.
So we had some challenges for hardware and software. I'm going to talk about the hardware. So the back of our LED panel was practically wired with completely stripped wires. This means that if a wire touched that was not supposed to, we could possibly fry the whole board, which would be really bad. So we had to find a way to make the wiring proper so that it didn't touch. We also had a limited number of digital and analog pins to use on our Arduinos. So we had to figure out what was the best method to make the most LEDs with the fewest amount of pins.
And in terms of software, the biggest challenge that we had was getting the 2 Arduinos to work together. Because we had one Arduino for all the positive wires and one for the negative, we basically had to have them set signals to each other continuously. But what this added was a slight delay. We had to find a way to work around that. And then a second challenge we had was with the machine learning, and we were trying to figure out a way to compare the 2 data sets.
So as you can see, Ashwin is moving his hand around the sensors. Right there, that's the machine learning protocol that we added. So we've currently completed about 2 of these steps you're seeing here. We've prototyped the design, and we've begun to review it, and now we've figured out some refinements we want to add. One of these refinements is using Arduino Megas. It's practically a bigger Arduino Uno. The Arduino Mega features about 54 digital pins and 16 analog pins. This would allow us to run our whole program on just one Arduino. This would allow us to practically remove the problems we've been having with I2C communication between our 2 Arduinos. We also want to 3D print a chassis, which would practically remove all the wiring issues and make it look a lot better for marketing.
And then another thing that we'd like to add is smaller sensors that would basically be more sensitive and be able to track LEDs the size of a small pixel, basically.
So we want to say thank you to our professors and our teacher fellow, Professors Ryan and Kurt, our teacher fellow Shirley, and our TAs, Luis and Lucy. Thank you.
So the award for this is, I think, self-explanatory. It's the most likely to cause epileptic seizures.